So today on the bench, we have this nice little wooden box here. Make sure the cameras are recording. I don't know if you can read this on the top or not. Return to Design Division, Code, Puget Sound, Naval Shipyard, Bremerton, Washington. And I guess there's a code 256 something written on here with a piece of tape. So this obviously came from the Naval Shipyard out in Bremerton. Let's take a look and see what we've got inside. Paddle with visual and cosine correction filters installed, 26 August 69. So it's a Weston Illumination Meter, model 603. So obviously it's for designing or measuring light. At least that would be my guess. Inside of the box, make sure we're on camera here. We've got a meter scale labeled in foot candles, various ranges. It's interesting again that the switch has more positions than the indication on here. It runs foot candles from 0 to 500, 0 to 100, or 0 to 25. And that must, of course, align to these three ranges. We've got what must be here the optical pickup. It's just kind of a heavy little wand, a very heavy cord, which is essentially a line cord. It's heavy gauge. The inside of the box over here is felt lined. It's a nice little box. It looks like the screws have been removed to allow that part of the mechanism to pull out, and it is falling forward. It lifts completely out of the box. So let me set this aside and we'll take a look at what we've got here. Oh, it's completely passive. So on the low scale, I've got the wand here just facing up towards my lab lights, and we're measuring about 23 perhaps foot candles, and if I cover it up, you can see the scale drop back down to nearly 0. The center positions between the high and low, such as here, do seem to indicate that it's off. Obviously the meter could be zeroed a bit better. There was a zero adjust up here, and of course as I move the meter around it would need adjusting. Well, that's interesting. It's completely passive. There's no batteries. There's just this heavy little wand with a couple of cells in it of some sort to detect light. There are what look to be some wire wound resistors here. They're numbered 1, 2, 3, and 4. I would assume those are wire wound resistors. And there's a range switch, which in high is making contact here. I don't know if you can get a view down into the switch mechanism. Those contacts are awfully dirty. It's a fully exposed switch mechanism. Again, I don't know if you can actually get a view down in there, the switch mechanism. It's a very simple switch. It's just connecting directly across two positions. I can see a piece of wire that runs across several of the tabs there inside. It's pretty simple. There's not a whole lot to this. The meter movement itself is in a very heavy casting here, potentially zinc maybe. some corrosion on that terminal. The entire thing's very heavy. Seems very well built. I'm not sure why this cable is so large, unless it's just to get a very low resistance. Because again, we're converting light directly into electricity here inside of it. I don't think I'm going to tear this down any further. I don't see a reason to try to remove this box. Interesting old piece of kit, and it's just literally for measuring light and foot candles. So it doesn't look like there's anything here I'm going to damage too heavily just by sitting that down. I'd like to take a look inside of this wand, or sensor, whatever you want to call it, just to see how it's put together. It's always interesting to look inside. Of course, this comes down to, do I have an appropriate small screwdriver here? I don't think that I do. This guy's going to be too big. Of course he is. My small flat blade screwdrivers have vanished. I think they're all downstairs, actually. This one's going to work. There's not a lot of tension on these. Just checking to make sure we're kind of on camera here, as I make sure I can break these all loose. Because there's always going to be one. No matter what you do, doesn't want to break loose. And in this case, I got lucky. They all came loose. Little tiny screws. Now, I'm sorry this isn't more complex object inside. Again, this is just one of those items that I believe a friend of mine picked up at local electronics recycler, maybe. This may have actually come from an estate sale. It's kind of a textured pattern in the back here. Doesn't feel like fiberglass, but it does feel like it might be some kind of a mesh with a resin. It looks like that's ready to lift off. Well, the phenolics broke there where it's been over torqued. The question becomes, since there seems to be two sensors inside of it, one here and one here, are they in series to produce enough voltage to deflect the meter? Are they in parallel because we need to generate more current? I don't know. We may be able to tell once we get down inside, or we may not. I'm sorry that my hand's in the way here on the camera. Just backing out these four little corner screws. Let's see if that plate will lift up out of there, and it does. I don't really know what that sensor is. We can see there's an outer ring that must be one of the contacts on the sensor that is connected to this piece of metal bar here. This one's got insulating tape on it, so it's isolated from that contact. We found one terminal, that outer metal ring. What is the other terminal on this assembly? I guess we're going to have to dig a little deeper into it. Something you may not have noticed here as I've been tearing this down, which kind of attests to the build quality, is this casting. Oh, that's interesting. There's a little metal ring there. It's a little copper washer, only hopefully you can see this in camera. It's bent to kind of make a spring out of it to create some tension. Can I read the back of this? Weston. So it's manufactured by Weston. It's got A is 29120. B, C, D, and E don't seem to have any markings in them. Made in USA. Again, let me get you a better view down into there. We've got the two sensors that are the white units. They've both got these copper pickups. So the strap seems to hook this one to the ring on this one. The way I'm viewing this, they are in series. The outside of this one to the outside of this one. To potentially, I don't know, it's hard to say looking at that. The thing I was going to comment on, and maybe didn't, is there's brass inserts cast into the plastic here. It feels like it's probably Bakelite. But you know, it's a nice build quality with the brass inserts for the screws everywhere. That includes these little hatches. Here that I took out, there's brass inserts behind these as well. Again, that's a nice attention to detail and nice build quality. See if I can get it to tear down a little further. And hopefully not destroy it doing this. I don't think that. Not sure what that was. Maybe a little bit of Loctite of some kind. Or a fiber washer. That screw's not going to pop loose. Let me see if I can. No, I'm not going to. One screwdriver's too big. The other one's too small. I don't want to do exactly what I just about did there, and that is slip off and damage something. Shoot, where am I? I think in a couple of videos here in a row now I've commented that my little flat blade screwdrivers have just all vanished. They've got to be sitting someplace on an unfinished project. Like I said, probably downstairs. So I want to be fairly careful here with this disassembly. Let's get a little split washer on it. Those are all the same. Okay, we're starting now to see the design of the sensors. I see it now. It's pretty obvious looking at it now. Oh, that's interesting. That one's got a contact assembly, and then it had the spring washer on top, and that one doesn't have a contact assembly. So the connection coming out of the cells is on these copper rings. And these just little tabs right here. And I'm going to see if I can lift this one up and out. It's got this piece of glass, which is now green, and some kind of a, I don't know if that's meant to be a filter, perhaps, probably. It looks like it's not aged well. And just this little plate here, this looks to be the photocell. See if I can get it back together. We'll take the voltmeter in a minute and take a couple of readings. This is the isolated strap. However, I need this guy here to go back in there. Get him to sit in place. So let's see, we're coming out of the bottom contact on that one to the bottom contact on that one, on the positive contact. So they are in parallel and not in series. Remember, we asked that question before. Are we trying to produce higher voltage to deflect the meter or sufficient current to deflect the meter? It looks like to me with two of these in parallel, it's about sufficient current to deflect the meter. This would work better if it wasn't raised. So we're going to put, wish I had something to sit it up on. It would make this assembly a little bit easier, because I've still got to work this cord back in. But for now, I need to set him back down inside of there. Start that screw. And this one comes across here. In my mind, looking at this, these little washers underneath these little screws that have dried out and fractured apart aren't for isolation. They may have just been there to keep things kind of torqued together well. For now, this little rubber heavy piece of line cord here is rather stiff. This is why I'm trying to back it a bit up so I can get those up underneath. Hopefully get that captured sufficiently. Get the screw down through there. We don't need this inside of there. Hopefully there's nothing toxic in this. Yeah, that relates just a little split ring lock washer. Get the long pick to help me with alignment here. Yeah, these look like they're just some kind of a little split fiber ring washer. I'm assuming just to keep the screw from working loose. Let me attempt to get this lined up again. And of course, the little washer here has slid off. nothing about this assembly is going to be easy. It might actually be easier to go ahead and mount that backing plate as I assemble this, because it'll put tension down through that front sensor and help maintain the height. Hopefully I've got this on camera. There's no reason for a lot of torque on these. This little washer, if I can get it up under there, sits in there. And that little spade sits between two of those. And let me see if I can get the hole lined up. And the little screw goes down through like so. It simply creates tension across that sensor. And then we've got the same thing on this one up underneath. The length is a little funny on this one, which might make this a little difficult to do. I know my hands are massively in the way here. I apologize. I have, as you may have surmised, rather large hands, which makes doing this kind of work always interesting. So we've managed to assemble ourselves back to where we were originally, at least electrically. We've got the insulating tape there and there to isolate that bar. We are wrapped around. The sensors are back in place. I'd like to clip on here and see if we can measure the output of the sensor, just to kind of get an idea of what it outputs. I'm attaching my alligator clips on the end of the probes for my Rigol 3058E. And I'm just going to simply clip onto the meter here. You probably can't see this. I'm going to clip on the meter here where the line cord comes in. Let's just set that down. And we'll see what we measure. So straight up into my LED lights, I've got 186 millivolts. If I cover it up, it's dropped down to 4 millivolts. So the output of this under my LED lights is about 186 millivolts. So the sensor is definitely still working. You know, some kind of early 60s photovoltaic. System there. Don't know all the details. Let's see if I can remember how this was snapped off. I believe it goes that way. That sits up in there. You sit down in there. The cleaner screws were on the inside, and the really dirty screws are on the outside. Of course, this could use a tear down and a real cleaning. I'll leave that to Jay, who owns this instrument. Hopefully Jay will eventually get some of her video content up on the web as well. She's working towards it, so tension on these screws. Again, it doesn't need to be astronomically tight. Most people over tighten screws, including myself at times. Just recheck the connections one more time. We know electrically we're getting an output still, so I haven't caused an open circuit or a short or something inside. This little back plate here, I don't know if you can see the pattern in it. It's almost like a fiberglass, and maybe it is flexible. It's a little bit like early circuit board material or something. I don't know. There is countersinks in all these holes, so this surface goes up so that the screws sit flush down in the countersinks. And the most interesting part here will be getting this cord back down in there flush. I think that's got it. Maybe that's got it. I want enough tension to act as strain relief on that heavy cord. Without so much tension, I snapped the little back cover here. Get him to start. Really doesn't want to start. There it goes. We'll make a couple more quick electrical measurements just to see what else we can detect or see here as it operates. Apologies for not having the voltmeter on camera. I still haven't figured out how to position everything where you can see everything I can. Oh, I hear Rosie back there. Little Miss Choking Coughing Girl. Elderly dogs are wonderful, even though she's got her little health issues. I adopted her at, I believe, about 11 years of age, and when you adopt an elderly dog, you So adopt their medical issues. Anyhow, the wand is back together. I'm satisfied with that. Let's go ahead and set the meter movement up here where we can see it. And I'm going to look for the delivered voltage directly across the meter movement. Of course, this will affect the meter a little bit. Where'd the meter movement go? Oh, geez, did I get the polarity backwards inside of the wand? I got the polarity backwards inside of the wand. I reversed those two wires. That's what I get for not testing before I force the assembly. Well, I won't bore you with watching me tear it down and reassembling it again. While I get the polarity correct, we'll return and make a few measurements. So I've gone ahead and I've taken the wand back apart and reassembled it. Let's go ahead and see if we can get that meter zeroed. That's fairly close. I noticed in playing with this earlier, oops, now that I've disassembled and reassembled it, the readings are much different. Before, we're now going off full scale. Before we were seeing about 25, 23, and actually now with it reassembled, I'm seeing closer to 30 foot candles. At this point, I think that's simply because there was so much oxide on the contacts inside of the wand that it increased the electrical resistance. If I get up closer to my lab lights, we're well over 100. I'm about a foot away from them. Let me stand up and get as close as I can actually get. I can't see where that deflection went to. What was it, about 150? Again, for calibration, no clue what the calibration on this is like, how good or bad it is. I would highly suspect it's way out of calibration just due to age and oxide and all that fun kind of stuff. Let's go ahead and see if we can get it to fall back out of the case again. As I said, we'll go ahead and make a couple of measurements and playing with it. I'm going to get directly across the meter movement just to get an idea of the voltage to the meter movement. We'll come onto the high scale. And that's a whole, it's about 3.2 millivolts according to my voltmeter, and that took it off full scale. The sensor a little flatter here. This heavy cord makes this sensor really difficult to position. So we're reading about 1 millivolt there, and we're a little over a third full scale. I don't see a marking on the meter for full deflection. It's just a Model 603, patent pending. Of course, with the meter attached, I think it affects the deflection a little bit, but we're at right at 1 millivolt to get to 40% of full scale. So this thing must be about 2.5 millivolts full scale. Like I say, on low. Let me see if I can position my hand and get us to near full scale. About 2.5 millivolts full scale is what it looks like. Yeah, 2.5 millivolts full scale on the meter. So it's a very sensitive little meter. Really interesting little instrument. It'd be interesting to do a complete teardown and restoration and get all the oxide removed from all that copper inside of the wand and cleaned up and nice and bright again. And perhaps figure out what that green mess on those filters were. I don't know if that was mold, perhaps. I tried not to disturb it. Or if it was just a filtration to only pass a narrow bandwidth of light to it. Again, not knowing exactly the application it was meant for. We'll come back here and take a look at the instructions. So, instrument indicates the illumination and foot candles based on the new candle on the surface of the light target of lumens per square foot evenly distributed. It is provided with a filter which changes the color sensitivity of the positive plates to match that of a human eye and can therefore be used to measure illumination of any color. That's interesting. So it's meant to kind of measure illumination as seen by the human eye. Set the range by means of the selector switch to measure the illumination of any surface. Place the light target on or near the surface with its resistive or sensitive plates parallel to it. Measure maximum illumination at any point from a luminous source. Place the light target within its sensitive plates perpendicular to the direction of the light rays. Paddle with visual and cosine correction filters installed. Instructions are practically unaffected by changes in external temperature, or the indications, I mean. Handle carefully. No excessive vibration or shock. So to prevent excessive heating of the sensitivity plates, or the sensitive plates, it's hard to read with the glare here, they should not be exposed to intense radiation containing a large proportion of heat rays longer than necessary to obtain a reading. Standardized at Weston Laboratories, New Jersey, USA, November 12th, 1963. Anyhow, I think with that, we'll kind of wrap this one up. I think it'll be relatively short. And we'll talk soon. Bye.